Hello, welcome to section 5.2, where we're going to talk about properties of exponents and scientific notation. Super exciting. So buckle your seatbelts. Okay. All right. Okay, so first of all, let's talk about what an exponent is. Okay. So just like how multiplication is repeated addition, right? So let's say, for example, 2 times 3, right? You would multiply 2 3 times. Add 2 3 times. And if you didn't know that, did you know that multiplication was repeated addition? Okay, so just in case. Well, anyway, exponentiation is repeated multiplication. So let's say, for instance, you have negative 9 to the 5th power. What you're basically saying with this little exponent is multiply negative 9 by itself 5 times, okay? So, it's negative 9 times negative 9, 5 times, okay? So here are parts of the exponent. You have, we call the big number the base, so whatever it is that you're multiplying. And then the exponent is the small number. So any a to the power m, sorry about that, a to the power m means to multiply a m times. Okay. See here. So product property. So exponents are very cool. They have different properties. So we're going to go through them. So let's say, for instance, I have 2 to the power 3, and I want to multiply it by 2 to the power 2. Now let's write them out so we could look at it. So this is 2 times 2 times 2. That's this one. And then this one is 2 times 2. So together, how many 2's do I have? I have 5, right? 1, 2, 3, 4, 5. So if you notice, there's a relationship. So when you're multiplying two exponents that have the same base, what we do is we add the exponents, okay? So pretty, not too bad. So here, so for A, let's go ahead and do a couple examples. So y to the 5th power times y to the 6th power is going to equal y to the 5 plus 6, which is equal to y to the 11th power, okay? For B, 2 to the x times 2 to the 3x is equal to 2 to the x plus 3x, which is equal to 2 to the 4x, okay? C, if you have 2a to the 7th power, 2a to the 7th power times 3a. Now, by commutative property, I can multiply these two together and then these two together. In other words, I can rewrite this thing, but you don't have to rewrite it every time. I'll do it this one time just to show you. This is commutative property happening, but we can kind of just do that in our heads anyway, right? So 2 times 3 is 6. A to the 7th times a is a to the 8th power, okay? So that's the multiplication property. Now let's talk about the quotient property. So if multiplying two exponents, same base, different exponents, means to add the exponents, what do you think that division would tell us to do with the exponents? So let's look at something, okay? So here I have, let's say I have 5 to the 3rd power over 5 to the 1st power, okay? Or fine, 2. Let's just let it be 2. So on the top, in the numerator, I have 5 times 5 times 5. In the denominator, I have 5 times 5. Well, look what's going to happen to the 5s. They're going to cancel out, And you're left with 5 to the 1st power, or just 5. So what happens? So basically what we do is we subtract top minus bottom. Now, what if the number is greater in the denominator? So let's say here, let's say if it was 5 squared over 5 cubed. So that's 5 times 5 on the top, 5 times 5 times 5. These will cancel, cancel, cancel. This is, since it's in the denominator, it's over 1. So this would be 1 over 5 to the 1st power. So notice that it's still 3 minus 2, except that now it's in the denominator. This can also be written as 5 to the negative 1 power. But we're going to go more into that. So anyway, so let's go ahead and simplify. Okay, so you can do top minus bottom, and if you get a negative, it's in the denominator. So let's see here, or bottom minus top, if the exponent in the bottom is greater, yeah? So for A, x to the 9th power over x to the 7th is 9 minus 7, which is x squared. Okay, for B, 3 to the 10th power over 3 squared, that's 310 minus 2, which is 3 to the 8th. Okay, For C, you have b to the 8th over b squared, b to the 12th. Okay, so so instead of writing, so you have b to the 8th over b 12th. But since it's greater in the denominator, I can do 1 over b to the 12 minus 8, which is 1 over b to the 4th power. Okay, and then for D, similar. So 7 cubed over 7 to the 5th power, since that's a 7. Since the 5th power is in the denominator, so that's 7 to the 5 minus 3, which is 1 over 7 squared, which is 49. Okay, so let's continue. Let's talk about the zero exponent property. Okay, so if let's say you have a number over itself like 5 over 5, okay? They both have exponent 1. So if I was to use the quotient property, that just means I'm going to subtract 1 minus 1, which is 5 to the 0 power. But we also know that any number over itself is equivalent to 1. So in general, any number raised to the 0 power is equal to 1. Okay, as long as it's a non-zero number. Okay, so let's see here. Let's say we have 9 to the 0 power, 1. B, n to the 0 power, 1. Not too bad. Okay, so property of negative exponents. So that's what we were saying earlier. Any exponent to the negative power is the same as 1 over that exponent. So it's like the reciprocal, okay? So let's say if you have 3 to the negative 2, that's 1 over 3 squared. Also, what if the negative is in the denominator? The negative is in the denominator, it goes to the numerator. So that's 3 to the power 2. Okay, and now the division property will make a little bit more sense probably. Okay, so x to the negative 5th power would be 1 over x to the 5th power. Okay, B, 10 to the negative 3rd power would be 1 over 10 cubed. Okay, you can go ahead, that's 1,000. And then C, 1 over y to the negative 4th, that's going to bring it up to the numerator, so that's just y to the 4th. D, 1 over 3 to the negative 2 power is 3 squared, which is 9. Fine. 9. Okay, that's that one. What if you have a fraction raised to a negative? Well, like we said, it's the reciprocal. So let's go ahead and do that. So for A, 5/7 to the negative 2 power is the same as saying 7 over 5 squared, which ends up being 49 over 25. Because it's times itself, right? 7 times 7 is 49, 5 times 5 is 25. Okay, so for B, you have negative xy to the negative 3rd power. That's going to flip it. So it's still negative y over x to the 3rd power. So that's just going to be negative y cubed over x cubed. All right, so let's see here. Let's do a couple more. Now let's use some properties together. So for A, you have z, negative 5 times z to the negative 3rd power. So negative 5 plus negative 3, that's just going to be z to the negative 8. But let's rewrite that without the negative. So that's 1 over z to the power 8. B, we have m to the power 4, n to the negative 3 times m to the negative 5, n to the negative 2. So we can combine them. We can use a commutative property. So that would be m to the 4 plus a negative 5. And negative 3 plus a negative 2. That's the same as negative 3 minus 2. And so then that's going to be m to the negative 1 power, n to the negative 5/5 power. So then that's just going to be 1 over, and that's m n to the 5th power. Okay. So let's see C. Let's do another one. We have 2x to the negative 6, y to the power 8, negative 5, x to the 5th times x to the 5th, sorry, y to the negative 3. So let's rewrite this. So this is going to be 2 times negative 5 times x to the negative 6 times x, sorry, this is an x, 5 times y to the 8th times y negative 3. So that just might help, you know, to see it. Because we're going to be combining the exponents, right? So 2 times negative 5, that's negative 10. Negative 6x to the power negative 6 plus 5 times y to the power 8 minus 3, or 8 plus negative 3. So then that's going to equal negative 10 x to the negative 1 power, y to the 5th power. So rewriting this, you know, this negative x goes to the denominator. Okay. All right. Let's talk about the next thing, power property. So power property, suppose you have, let's say you have 3 squared and you raise that to the 3rd power. So what does that mean? That means this exponent, that means repeated multiplication. So basically you have 3 squared times 3 squared times 3 squared. So then 2 plus 2 plus 2, that's 3 to the 6th power. So notice what else? 2 times 3 is 6. So in general, any real number that's, you know, non-zero, raised to a power, well, I guess 0 would still be, it doesn't matter because 0 to the anything is 0. To an exponent that's raised to yet another exponent, you just multiply the exponents. Okay, now this is different than adding. Notice what's this? There's similarities and there's differences. And the difference is that, look, there's only one base. For when you're adding the exponents, you're actually multiplying the bases. So you'll have more than one. Okay, so basically all you do is multiply the exponents. So for A, y to the 5th power to the 9th power is y to the 45. B, you would have 4 to the 28th power. C, y to the 3 times 6 is 18. And then D, y to the 5 times 4 is y to the 20th power. Okay, so that's power property. What about if you have a product to the power property? Well, it's the same thing. You're multiplying it by itself that many times. So let's say, for instance, I have 3x, and I want to raise it to the power 4, right? So then that means 3x times 3x times 3x times 3x, right? Let's do commutative property, 3 times 3 times 3 times 3, right? And then these guys together, x times x times x times x. In other words, that's 3 to the 4th power, x to the 4th power. So it's kind of like you're distributing the exponent, okay? And it goes to every single number or variable. So let's see here. Let's do some examples. Excuse me. If you have negative 3mn to the power 3, that's just negative 3 cubed times m cubed times n cubed. In other words, negative 27m cubed n cubed. How about B? Oh, that's a nice one. Negative 4a squared b to the 0. Since this 0 applies to all of this, that's just equal 1. Okay. C, if you have negative 6k cubed to the negative 2 power, you can flip it and then, distribute the negative, or you can distribute the negative and then end up flipping it anyway. So this is the same as saying 1 over negative 6k cubed squared, which is equal to 1 over negative 6 squared k cubed squared, which is equal to 1 over 36k to the 6th. Okay, and then finally D, you have 5x to the negative 3 squared. So let's multiply. So this is going to be 5 squared, and then x to the negative 3 squared. So that's going to equal 25x to the negative 6 power. But this negative, we can write that in the denominator. So 25 over x to the 6th. Okay, and quotient to a power. So we did product to a power. Now we do quotient to a power. So same thing. Any quotient that's raised to a power, you can exponentiate the numerator and the denominator. Because let's say, for instance, we have 2/3 raised to the 3rd power. That's just going to be 2/3 times 2/3 times 2/3. But if we multiply across, that's 2 times 2 times 2 on the top. Sorry. Over 3 times 3 times 3, which is just 2 cubed over 3 cubed. So you see what I'm saying? So that's what this is. Okay, so let's do some problems. So for A, we have b to the 4th power, 3 to the 4th power, and we're good. So for B, first let's get rid of the negative by doing the reciprocal to the 3rd power. So then that's just j cubed over k cubed. All right, so then C, we have 2x squared, xy squared. So 2xy squared, that's raised to the third power over z cubed. Now, let's go ahead and distribute this. Remember, that's 2 cubed because this is 2 to the first power. X cubed, y, 2 times 3 is 6, all over z cubed. So then that's just 8 x cubed y to the 6th over z cubed. Sorry, z cubed. I don't know what happened there. Okay. Okay. And then finally for D, should we do D right here, I guess? It's 4p to the negative 3 squared over q squared squared. So then that's going to equal 16 p to the negative 6 over q to the 4th, but then this negative moves it down. So then that's 16 p to the 6 q to the 4th. Okay, so don't forget, like after if you have a negative in your exponent and you move it to the numerator if it was in the denominator and vice versa, don't forget to get rid of the negative because that means you used it already, okay? Okay, so just to recap, all this stuff we've talked about. Product property, so if you multiply two variables that have, two numbers or two terms that have the same base but different exponents, you add the exponent. So an example, 3 squared times 3 cubed is equal to 3 to the power 5. So notice the base stays the same. Power is a base raised to an exponent raised to another exponent. You would multiply them. So 3 to the 2 to the third power is equal to 3 to the 6th. So see the difference? Then you can distribute, subtract, right? We're subtracting top minus bottom. Anything to the 0 power is equal to 1, okay? You can distribute to quotient as well. Anything to the negative power is the reciprocal of what it is. And that's for both of these. Okay, so now that we know all of this, we get to use them to simplify stuff. So let's do a couple of these. So here we have, here for A, you have 3x squared y to the 4th power. I don't know why it does that. Okay. Sorry. 3x squared y to the 4th. Y, 3x squared y, and all that is to the 4th. So 3 to the 4th, x, 2 times 4 is 8 today, y to the 4th power. So that's the first one, times, then we have 2 cubed, x cubed, right? And then y to the 6th. So now, let's combine this. 3 to the 4th power is 81 times, and then the numerical part, let's just move it over, right? 8 times, and then you have x to the 8th times x to the 3rd, that's x to the 11th power, and then y, 4 plus 6 is 10 today. So now this is going to be what? 648 x to the 11th, y to the 10th power. Okay. Alrighty. For part B, we have x cubed to the 4th, so that's x to the 12th because we're multiplying. Why was I going to write 14? I don't know. X to the 12, 3 times 4 is 12 today. Yes, it is. Okay, negative 2 times 5, that's x to the negative 10 all over. And then 6 times 5 is 30, x to the 30th power. On the top, let's combine this, right? We're adding because it's the same base. But 12 plus a negative is just 12 minus 10. So x to the 12 minus 10 over x to the 30th, that's just going to be x squared over x to the 30th, which is just going to be 1 over x to the 30 minus 2. So that's going to equal 1 over x to the 28th power. All right. And then for the last one, C. Let's go ahead and do that. So you distribute on the top, distribute on the bottom, and then let's continue. So we have here 4, 2 times 2 is 4 today, x squared y to the 4th over x to the 6th, y to the negative 4 times, and this negative just means to flip it, x cubed y to the negative 1 over 12xy cubed. So it's just important that you can see how distribution and all of that works. Okay, so, and, when you perform the operation intended by that exponent, it's really helpful to just do that one operation, write the next line, then do the next one, write that next line, and then start thinking of it as every line is a new problem, okay? So that way you don't get so stuck or overwhelmed. Okay, so here, we're going to multiply across the top because that's what fractions do. So let's see here. So on the top, we have 4x squared times x cubed, so that's x to the 5th power. And then we have 4x to the 4th power times y to the negative 1. That becomes 4 minus 1, which is 3. And all over. And then on the denominator, I have a 12. X to the 6th times x gives me x to the 7th. Y to the negative 4 times y cubed is y to the negative 1. Okay, so, and then this negative brings it up here. So really what we're looking at is 4 over 12 reduces to 1/3. X to the 5 over x to the 7th, that's going to be x squared in the denominator. And then here we have y cubed times y because of this negative 1. So then final answer is y to the 4th over 3x squared. Okay. Okay, so last thing we're going to talk about is scientific notation. So scientific notation is basically a number between 1 and 10 where you're writing the zeros in a shorthand way. So let's say here 4,000 is the same as 4 times 1,000, which is equal to 4 times 10 to the 3rd power. Okay, now here 0.004 or 4 thousandths, right, is 4 times 1/1000th. This 1/1000 can be expressed as 1 over 10 to the 3rd power, which can be, by property of exponents, rewritten as 4 times 10 to the negative 3. Okay, so notice, interesting, so if you have 4,000, and I want to write this in scientific notation, I move it here, 1, 2, 3, I count the zeros. So that's the same as saying 4 times 10 to the 3rd power. Now, a good thing to check yourself is, this is a big number. This is not a decimal, so of course this will be whole, right? This is positive, I mean. So now here if you have 0.004, 1, 2, 3, I moved it to change it into 4 times something else because it has to be between 1 and 10, right? Not 10. I moved it 3 times, so I'm saying I moved it to the right, so that's 10 to the negative 3 power. In other words, if it's a decimal, there should be a negative in the exponent. So if you want to convert from decimal to scientific notation, to scientific notation, okay, first thing you need to do is you need to move the decimal point till you get to the first number is greater than or equal to 1 but less than 10. Okay, and then count the number of decimal places that the point was moved. And then we write the number as a product with the power of 10. If the original number is greater than 1, or in other words, is large, right, the power of 10 will be a positive. And then between 0 and 1, a decimal, the power of 10 will be negative. Okay, so let's say here, so for A, I have 37,000, and then here's my decimal, right? Anytime there's a whole number, the decimal is like right there, even if we don't write it, we know it's there. Okay, so if I want to write this in scientific notation, I got to move my decimal up to like 1 digit away, right? So that means I need to move it 1, 2, 3, 4 spaces. Okay, so that gives me 3.7. And I moved it 4 spaces, so that's 10 to the 4th power. Okay, what about for B? I have 0.0052. I need to move it, so that it's the form number dot number, I need to move it 1, 2, 3 spaces, the decimal, so that's 5.2 times 10 to the, and then I moved it 3 spaces in the negative direction, right, because it's a decimal. Now, if I want to go from scientific notation to decimal, it's very similar. So let's go ahead and look at this. So here I have 9.12 times 10 to the power 4. 10 to the power 4 is 10,000, okay? So when I move this, I get 91,200. Now, if I multiply 9.2 times 10 to the negative 4th, that's Negative fourth power is 1/10,000. So 1, 2, 3, 4 decimal places. So 9.12 times this is going to end up giving me 0.00912. Okay, so basically, if you're starting out with scientific notation to decimal, if you have a positive exponent, you move it to the right. You move the decimal point that many spaces to the right. If you have a negative exponent, you move it to the left and stop. So here, you say, okay, here's 10 to the fourth, 9.12, 1, 2, 3, 4. So then you add 2 zeros. Okay, and then here, 9.112 times 10 to the negative fourth, if I move it over 1, 2, 3, 4, 0.123912, I moved it to the left decimal 4 places, the decimal 4 places to the left. Okay. So you figure out, first you need to see if it's positive or negative, the exponent. And then if it's positive, you move it to the right. And if it's negative, you move it to the left. Okay. So here, let's do 6.2 times 10 to the third power. So 6.2 times 10 to the third. That means that 6.2 is going to become 1, 2, 3. Okay. That's going to be 6,200 or 6,200. Okay. Now for B, you have negative 8.9 times 10 to the negative 2 power. So that tells me 2 spaces to the left. So 1, 2. So negative 0.089. Okay. So that's that one. Okay. So now let's do two problems with scientific notation. So because of commutative property and property of exponents, this becomes super easy. So here we have negative 4 times 10 to the 5th power times 2 times 10 to the negative 7th power. So combining the whole numbers, that's negative 8 times, and then 10 to the 5th power times 10 to the negative 7th. So 5 plus negative 7 is negative 2. Okay, but then again, remember this is, we want to write it in decimal form. So that means that we're going to move it to the left. So that's going to be 1, 2 spaces to the left. So negative 0.08 is going to be our final answer for that one. And then for B, we have 9 times 10 to the third power, 3 times 10 to the negative 2 power. So 9 over 3 is just 3, right? And this negative is the denominator, so I can write that up here. So 10 cubed times 10 squared. So that's just 3 times 10 to the 5th power. So if I move it to, if I want to write it in, non-scientific notation form, that means I need to go to the right 5 spaces. So 3, so then that's going to be 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. That's going to be 300,000. Okay. And that's it for this section. You did it. Good luck. Happy studying, and I will see you in the next video.